Hi everyone, in this video we're going to look at the cubic function. We're not going to go into too much detail because there's not much you can do in terms of sketching without doing a bit of calculus. So we're going to look at, if I just scroll down, sign diagrams, which can help you sketch your cubic functions. And also here I've just taken from your textbook different forms of the cubic. You can look at transformations as well. So if I just get my pen up, so I'm not very organized. Here's our general form of the cubic. So you can see all your transformations there. But what we have here are examples in expanded form or polynomial form. So you can factorize these to get your x-intercepts, which is what we're going to focus on today. All right, so some of this we've already covered. Some of the theory behind cubics you've already covered. I'm just going to go through sign diagrams. So basically, your sign diagrams just tell you when you're below or above the x-axis. So what we've got here is 3 x-intercepts, okay? And basically what we have with this sign diagram is we're below the x-axis here until we get to alpha, and then above until we get to beta, and I think this symbol is gamma, and then we're back above again. So if we think about the graph, we've got our 3 x-intercepts, and I don't know what they are, so I'm just going to put 3 in. So it's going to be really hard to do this small with a pen. All right, and then our graph, so we're starting off below the x-axis until we get to alpha, and then we go above the x-axis until we go to beta, and then we're below again until we get to gamma, and then we can go back up again. That is the worst cubic I've ever seen, but basically that's what a sign diagram, how you read your sign diagram. All right, so the only example I have here is example 2. I'm not going to factorize them by hand. I want to keep this video short. We've already done factorizing in a previous section, so I'm just going to use the calculator. So to factorize, we can just go to interactive. Now let me see if I can remember where it is. All right, transformation factor, and then you can just go to factor and type in your expression. So we've got x to the power of 3 minus 4x to the power of 2 plus x plus x plus 6. Now I'm going to just change that x because there we go. All right, so the calculator has factorized it for us. So I'm just going to write that next to this in factorized form. X minus 2, and I didn't really leave much room for these questions, I apologize. All right, so this means your x-intercepts, oh gosh, it's a terrible x, are at x equals -1, 2, and 3. You've got a y-intercept at y equals 6, okay, so I can see that with the constant. So when we're graphing it, and I might get rid of that graph over there, just so I've got a bit of space. All right, my computer died again, which is explains why maybe something has just disappeared from your screen. It's very frustrating. I don't think this computer really likes creating videos and writing on them, and maybe even this document itself, having all this writing is probably using up too much memory. Anyway, so we did have a y-intercept of 6, and our 3 x-intercepts were -1, 2, whoops, that's not really, we'll do that as 2 and 3. Oh gosh, that's terrible. All right, so in drawing our, what do you call it? I can't even talk. In drawing our cubic, we know it has to go through -1, 6, and then it comes back down to 2 and 3. Now it's stationary point, so the point where it turns. Okay, we can't work that out at the moment without the use of calculus. So what I would encourage you to do is to actually just graph it on your calculators. So if we just quickly graph it. Sorry, I probably should have done this before. Minus 4x to the power of 2 plus x plus 6. Oh, we didn't have to sketch the graph. That's all good. I don't know why I'm sketching it then. All right, so let's have a look at the graph. So there's our cubic. All right, so we can see it's going through x equals -1 up through y equals 6, and then it comes back down. So if I were to sketch that here, all right, so we're going up, going through -6, comes back down to 2, and then goes, oops, very wonky, but at least you've got a good, an accurate one on that calculator. So for your sine diagram, all right, so if this were, say, the x-axis, that blue line, this, oh gosh, what am I doing? Sorry, I was meant to draw a plus sign and I was about to draw an x. Okay, so this is when we're above the x-axis and this is when we're below. So instead of writing alpha, beta, and gamma, we've got -1, 2, and 3, and they should probably be a bit more to scale. So we're below the x-axis at -1, so I'm going to have below the x-axis. Then between -1 and 2, we're above the x-axis. And between 2 and 3, we're back below the x-axis. So I'm just going to put those lines in. And then we go back up when we're past 3. Okay, so that's what you would do with your sine diagram. So you can try factorizing these by hand if you like, or just to use your calculator. If I just go back to our main screen, just to show you how to factorize again on your calculator, interactive transformation factor. All right, and then just type the expression up there. So for the next one, we've got 4x to the power of 3 plus 3x squared minus 16x minus 12. All right, so there we've got x plus 2, x minus 2, and 4x plus 3. So I might just do this one here. Do b up here. All right, so when I factorize that, I got x plus 2, x minus 2, and 4x plus 3. Remember, these are all the factors which we can use to find your x-intercepts. So basically all we do is x plus 2, your factor is equal to 0, so x is equal to -2. And for the second factor, we've got x equals 2. And for the last one, we've got 4x plus 3 equals 0. So you can just rearrange that. So 4x equals -3 and x equals -3 on 4. So when you're doing your sine diagram, just make sure you write your numbers in order. Okay, so you'd have x is -2. Might do that down here. So we'd have -2, -3 on 4. And then what was our last one? 2. And then just doing your sine diagram. So if you want to check, so what I might do is copy actually. I don't know how to copy on here. Let's just see if I can do it. Good. All right. Transformation factor. Oops, no, we don't want to do a factor again. We want a graph, sorry. No, we'll get rid of that one. Put the second one in. I'm going to graph that. All right, so if we just zoom out a little bit. Oh, and I forgot to put the y-intercept. I'm not too good at zooming. But you can see we're going through -2 and -3/4 and 2. And your y-intercept is -12, but I can also just scroll down. Nope, I can't scroll down too easily. I might have to change the window. With your turning points, again, we'll do that later when we do calculus. Sorry, a bit of a blank. All right, so for -2, we're below the x-axis, so remember plus and minus. So up until -2, we're below the x-axis, and then between -2 and -3 on 4, we're above the x-axis, and then between -3 on 4 and 2, we're below, and then we go back up. So your sine diagram is going to look something like that. All right, I'm going to leave it there because that's all for 4E. But just remember, use your calculator a bit for the factorizing. For this one, it's more to do with thinking about when the graph is positive and when it's negative and so forth. All right, bye girls.